Energy Transition Now with David Linden.
Hello everyone, I'm your host David Linden, the Head of Energy Transition for the Westwood Global Energy Group, and you're listening to Energy Transition Now, where we discuss what the transition really means for the oil and gas and the broader energy industry. After the summer break, at least here in the Northern Hemisphere, we're now back with today's episode officially kicking off Series 2. After speaking with mostly operators in our first series, this second series will take a look at the technologies and finance needed to make the transition a reality. The topics reflect the feedback we received from our Energy Transition Survey, so thank you for taking part, and I hope everyone enjoys what comes next. To get the ball rolling, we wanted to take a closer look at how you design or adapt projects to make them compatible with a low carbon future or a lower carbon future. And to help us with that, we have our first dynamic duo, Duncan McLachlan and Safina Jivraj from the self-styled Project Architects and System Integrators IO Consulting. Safina is the Technical Director for Environmental Consulting Services at IO Consulting. She holds a master's degree from Imperial College in Environmental Engineering and has accumulated 25 years of experience in the oil and gas, refining and energy sector. While at IO, she has expanded into energy transition, where she is a segment lead for emissions reduction and decarbonisation. Duncan is a physicist and systems thinker with 20 years of experience leading successful innovation teams across the automotive, defence and energy sectors. He is currently the Director of Systems Engineering at IO Consulting, where he deploys model-based systems engineering, MBSE, techniques to facilitate the digital and energy transition. A warm welcome to you both.
Thanks, David. Good to be here.
Fantastic. All right. Well, I think before we begin with the topic of today, we're looking at how you design and try and at least adapt your projects for a low carbon future. I think it will be helpful for listeners to understand a little bit more about IO Consulting. They might not all be familiar with you. So Duncan, maybe if I could just ask you sort of the opening question, who is IO Consulting?
Well, it was great to hear you say in the introduction that we consider ourselves a project architect or a systems integrator, because that fundamentally sums up what we do. We were formed in 2015 as a joint venture between Baker Hughes and McDermott to bring more certainty to the front end of projects. And that's where that project architect piece comes in. We currently have about a 50-50 split in our work between hydrocarbon projects and energy transition projects. And we work with a decision quality framework, which is designed to mitigate cognitive bias, which is where we start to bring in this more certainty piece. And we also use a holistic systems approach to our projects that allows us to both create and maximize value in the early concept phase, but then protect it through the later phases of the project. And we do this with a multidisciplinary team at IO Consulting, and we supplement that with the expert knowledge from both of our parent companies.
Very interesting. We'll certainly come back to, I think, some of that systems thinking a little bit later, because I think that's going to be quite important as to how we think about some of this. But as you sort of say, half your projects are sort of energy transition focused, and I'm assuming part of the hydrocarbon ones are also about how to think about the future and how to think appropriately about those. And I recall, you've made some net zero pledges, and you've talked about energy transition a lot, etc., which is one of the reasons I was keen to bring you on. But maybe Safina, can you just talk us a little bit more around how is net zero as a concept actually ingrained within kind of the IO Consulting business?
Yeah, certainly. To start, it's front, back and center. We're very serious about energy transition and net zero. There is this recognition within IO that we coexist within a system, the system being the globe. It's not possible to shift one piece, at a time. We have to work together, industry and individuals. Recently, we read a book by Mike Berners-Lee, which is called How Bad Are Your Bananas? And it starts to talk about, how individual choices or people's choices have an impact on carbon and people's carbon footprint. And it became very apparent that, we all have a part to play in decarbonisation to protect the future, protect the world for future generations. So, we started by taking an approach of having skin in the game. And our mindset has really been about, we can't really sell energy transition to the industry without making commitments within IO itself. So we have gone through a process of understanding what our carbon footprint is. And we've gone and we've aligned with the Science Based Target Initiative in setting our ambitions and targets. So it became really clear at the beginning that when we were setting our targets that we don't have scope 1 and scope 2 emissions. And, sometimes it would have been very tempting to stop there, but we took it a step further. And, our pledge is now based around ambition 3, which is the most stringent of the ambitions, which, if those that aren't familiar, it limits global warming to well below 1.5 degrees above pre-industrial levels. So this is just for scope 3. And so there's going to be quite a degree of shift change within our operations to be able to accommodate that. But what it really translates to is a 50% reduction in scope 3 emissions by 2030. And I think this commitment to net zero within our operations has been really welcomed by our clients. So I think it's all been quite positive.
Perfect, Safina. And maybe just as a quick follow-up question to that, in terms of your commitment there, does that mean your client base changes as well, or not really? Or is it you are working together with your client base to ensure that they also ultimately, because they are your scope 3,
Yes.
so is the client base changing, or is it what you're doing with your client base that's changing?
I think a bit of both. So, our client base is changing. We're starting to work with industries that are not predominantly oil and gas. So that's interesting. But we're also working with our parents. I don't know whether it was mentioned in the intro that IO is part owned by Baker Hughes and McDermott. And we've been working really close with both entities on decarbonising what we call embedded carbon in the process. Through looking at, how can equipment be manufactured at low carbon, and also looking at the EPC, the engineering process, and how we can improve that process to reduce carbon in their footprint as well. So I think the nature of the business is changing. We all have to work together, as said.
Thank you. No, certainly. I mean, Baker Hughes and McDermott obviously also known for making their own commitments and leaps and bounds in that space. Now, Duncan, let me come to you though. In terms of, we talked about the idea of the topic for today being working out how do you, design for a lower carbon future as such. And of course, maybe a good starting point is to talk about new things that you're going to build, that you're going to design and put out there. With that sort of topic in mind, how do you work with your clients when you're thinking about net zero facilities?
Yeah, I think that concept of new facilities is really important with regards to the pledges that oil and gas operators have made, whether it's 2030, 2040, 2050. In 2050, the assets we're building today are still going to be operating. It falls within that lifetime. So what we're doing today has to be aimed towards net zero to help our clients meet those objectives and those commitments. And as part of that, in 2020, we led a collaboration between McDermott, Schneider Electric, and IO to develop the concept for a net zero offshore facility. We selected a reference case of a gas compression facility. We chose one that was fairly standard in terms of its basis of design. And we set out to see how we would redesign that as a net zero facility. And we successfully achieved that, a 76% reduction in the operational emissions. The net zero element came from an offsetting. For the sake of the study, we constrained ourselves to engineered offsetting solutions only. So we'd looked at some direct air capture there. And that was only for a 2% increase in the total cost of the facility. So relatively small increase in cost to achieve a massive difference in the emissions footprint of that facility.
Very interesting indeed. And if I listen to you there, are you suggesting also, though, that for greenfield, what you need to do is almost go back to first principles when you're looking at something? You chose an example there around a gas compressor, but let's say, I don't know, it's an LNG facility or another platform or anything like that. Each time you need to go back to sort of literally first principles and have that mindset of how do I actually achieve this here and create and balance it between different factors at play.
Absolutely. And one of the key takeaways that we had, we applied it to a specific concept, but the methodology can be extrapolated out, and that idea of first principles is key to it all. So when we traditionally approach a study for our clients, we'll work with them to identify the value drivers, what good looks like. And more often than not, those are economic metrics. It's minimize the capex. It's how do we maximize NPV? Those type of things. For this study, this net zero study, we constrained ourselves only to focus on the reduction of emissions. And it's very interesting as we were going through our workshop sessions and we were coming up with ideas, and then someone might say, yeah, but that's going to put a lot of cost into it. And then everyone else would jump on them and say, we're not thinking about cost in this. We've got to focus on emissions. So it was absolutely changing the mindset, and it was taking it right back to first principles. And it was a pleasant, I won't say surprise, that's too strong, but really pleasant to find that there was a fairly insignificant increase in the cost, and we purely focused on emissions reduction to achieve that.
Fascinating. Yeah. I guess it'll be a case-by-case basis, but fascinating anyway. But I guess the biggest problem, I guess is the word, that's out there is obviously 99% of things are brownfield, not greenfield, though. And so the biggest challenge right now, certainly for the oil and gas industry, but also broader, is how do you actually approach or think about brownfield or operating assets? What's going to be different there?
Shall I take this one, Duncan?
Yeah.
Please. Okay. So, there's two factors at play. So reading all the IEA reports, there's going to be a need for oil and gas well beyond 2040. And most existing operations, their design life, the clients who are speaking to us, the design life of operations go beyond 2030. And so we were being asked, what do we do in this early transition space, to support brownfield operations, because they're not just going to shut the doors because of carbon, climate change impacts. So we devised a methodology called the emissions reduction sprint that really takes a deep dive into each asset and to identify and explore emissions pathways of a facility during its operating life. Now, there are the sprint itself has 6 components. The components start with, the framing to understand, what the value drivers are. As Duncan said, it forms very similar in a similar process to the decision quality matrix or the decision quality process that we apply for our concept design projects. But it starts by framing, understanding what the boundaries of the review is, and then looks at baselining, and then we start to identify what the pathways look like. The next step is then looking at screening, based on the value drivers, to look at technical viability of the solution, looking at the technical readiness levels of the solutions that we're proposing, but also looking at business continuity. One of our clients quite recently was saying, that, look, we have a need to change our kit today. This is aging equipment. Do we change it like for like? Do we start to consider 2030 considerations, or do we start to look at what does the net zero pathway look like? So there are some challenges around that, because it's a time constraint issue. There is a cost issue. It is more complicated to do brownfield modification. You have to fit it within a window for planned plant shutdowns. There is constraint, space constraint issues, changing people's mindsets, operations mindsets as well. They've been doing things a certain way, and they may not be open to changing the way the plant is operated. There's also issues around, feasibility. One of the things that we looked at with greenfield is that there is this opportunity to electrify. When you have compressors, boilers, turbines, power generation equipment on site that predominantly runs on hydrocarbons, it makes it very difficult and costly to look at revisiting all of that design, and looking at applying electrification processes as well. So I think there is also this consideration of how feasible is the whole process. It makes it more difficult, I think, for brownfield than greenfield. With greenfield, you've pretty much got a blank sheet to work with. Brownfield, it's a more involved process.
Okay, and it sounds like it's rather complex because, as you say, it's about technical feasibility, it's about cost, it's about, is there some government support maybe that's out there to help you choose a certain pathway above another?
Yes.
And therefore the decision making is quite complex. But kind of listening to you, you need to come in with that mindset straight away and look at all your different options and roll those out. So is it therefore fair to say it's really quite specific by geography, by the age of the infrastructure that you're looking at, by the owner, etc.? Is really, those are some of the factors that are going to drive ultimately what you can and cannot do.
Yeah, and this the methodology that we have, we can apply it to a single asset, or look at a portfolio of assets. So there may be more opportunity in the portfolio to look at certain assets and look at reductions on certain assets. Whereas others in the portfolio might be brand new. And when you look at energy efficiency, that might be right at the top of the curve. So there may not be as many opportunities there as some of the older assets or mid-ranging assets. So I think that you have to go in there with the mindset. You have to go in there with the mindset of looking at technical readiness of solutions, because I think the industry is very risk averse generally. So to then look at changing operations to operations that people just aren't familiar with, and getting people behind that, I think becomes a challenge that we all have to look at. Also, once you have operating facilities, what's been interesting for us is when you design something and when you actually go to operate it, the actual conditions for operation might be different. So the plant may not be operating at its optimal. So there are opportunities there, as Duncan said about compression. There could be a rewheeling or rebundling of compression to optimize the plant. There could be opportunities of, questioning, why are we flaring and why are we venting? Is there another opportunity there? Decisions on selecting valves and equipment that are kind of leaky. That's perhaps been made on a LARP and what's tolerable, and a cost basis. But now we're really challenging ourselves to say, can we put in better items of equipment to manage fugitive emissions and manage the leakiness of the site? Because ultimately, if a facility leaks less, it's more revenue to the operator. So that there is a benefit there, certainly.
Okay. Yeah. No, obviously, that always is a nice nice cherry on top that people will also be looking for increased profitability as well as improved emissions.
And I think one more thing to add there is that, what we're also finding is that there are some solutions that, where operators are quite single-minded in the way they perhaps deliver a solution or operate their site. They're quite protective of their facilities from a security perspective. Some of the solutions that we're looking at, like CCUS, it has to be a collaborative effort to make some of these solutions viable. So, we're seeing far more engagement, seeing it in the UK with Teesside, and Net Zero Teesside, and other regions around the UK where industry is coming together, to meet that low carbon pursuit. So it's quite exciting. We're working in a very different way to how we used to.
Perfect. No, I like it. Certainly, collaboration and engagement is something that we try and talk about a lot as well. I did want to ask, just in terms of if someone was to visualize this in their mind, I can see that in a greenfield situation, you can start and go, right, I want to get this facility as close to net zero as I possibly can. I might need to mop up some of the rest of it with some carbon capture or offsets or whichever methodology you wish to use. But you can achieve quite significant carbon reductions. From your experience, is it fair to say that brownfield, you're only ever going to get to a certain percentage because of just the way it's been designed from day one? So you're not going to get a net zero, let's call it, facility, or not so close to, because there are just simply fewer things you can do because the day one design hasn't been appropriate. And I asked the question with a kind of macro kind of hat on here, thinking, okay, if the world wants to get to net zero, but actually a lot of it's been designed not with net zero in mind in the first place.
Yeah.
How far can you really go before you need to do other things?
I guess it's about mindset, and there is certainly some truth in what you've said. There is a facility can only really be optimal at its design. So that there is that aspect of it. So you can remove, you can do energy efficiency, you can look at changing out items of equipment. It's about how much money and capital is available to make these changes. But also we have to look at tail gas treatment. There is the opportunity for carbon capture. There is the opportunity for indirect or direct capture solutions. So I think it's about how willing a operator is towards greening or getting to a net zero solution. And I think there is also funding available from government to, which challenges the mindset as well, that, it might not be viable, commercially viable to go down a certain route. But, if there is demonstration that, there is a carbon reduction through changing the design, there are grants available by government to enable the process. Don't know, Duncan, whether you want to say anything.
I wanted to echo what you said on the mindset and just draw on an experience I had from working in the automotive industry early in my career. So it was a manufacturing industry. We were launching some of the world's first electric steering systems. We had an experience where we had two clients. One client set as a target of a failure rate of 30 parts per million. And then we had another client that set as a target of 0 parts per million. Your target failure rate was 0. And after much wailing and gnashing of teeth about how we would never be able to do it, and design had to have some level of failure in it, the client who set the target of 0, we achieved a sub 5 parts per million failure rate, so pretty damn good. The client who set as the target of 30, I seem to recall, I think we were around the 20 parts per million. And that mindset of if you set a target of 0, you're going to get a lot closer to it than if you set a target of 30. And I think that mindset is really important because it really forces you to push the boundaries in terms of what you can do.
Yeah, no, certainly other industries, maybe sort of the food and beverage industry or so, that talk with their supply chains a lot and work very closely with them. You see that attitude there around, let's work together, let's get the right KPIs in place, let's agree on those stretch targets, and we'll work together to try and make them achievable as such. But I guess, as you were saying there, we've talked about some of the things that can sort of facilitate getting to net zero a little bit more. We talked about funding, the willingness, the mindset, collaboration, all those different things. But of course, what we're trying to do is not just change oil and gas, we're also trying to change or adapt the whole economy as such. And Duncan, you talked a little bit about the automotive sector and the mindset there, and how that mindset translates. But how does some of the work that you're doing apply to maybe other hard to abate sectors, and the sort of mindset or the approach that you take? How does it apply there?
Well, certainly we're all running at the same pace. It's not just the oil and gas sector that is looking to decarbonize. Along with the oil and gas sector, there's the power industry, the steel manufacturing industry, the cement manufacturing, mining. We're all challenged to look at, how can we reduce carbon from our facilities. One of the clients that I'm working with, they're really looking at, what can they do now? And part of what they can do now is they've set ambitious targets for decarbonisation, and they're looking at, is fuel substitution an option for them? Moving into the hydrogen space, is electrification an option for them? That we're all working together and learning from each other about, how to pursue this, how to decarbonize our various sectors. One of the things that one of our clients are looking at is, if we change out all of our kilns heaters to electrical fired heaters, what impact does that have from heat distribution perspective? That it's understanding the feasibility, but also, if they are able to do that, what power purchase agreements can they put in place so they just ensure that they take the renewable portion of the power purchase, the power from the grid. So it means that, they're greening their facilities and shifting. I think emissions from scope 1 into scope 2 means, as the power sector greens, then the industry takes advantage of that as well. So that's just one area that is being looked at, I think, by the hard to abate. And where there are no other options, there are industries like the steelmaking industry in Wales, that they're looking at collaborative approaches and looking at CCUS. So yeah, I think we're all moving in the same direction, and we're all trying to learn from each other, because it's just so fast paced. 2030 will just come around before we know it, and we can't just wait for someone else or another sector to take advanced steps. I mean, what we can say is that there is a lot of learnings from the oil and gas sector, because we've been measuring carbon this is not just a new thing for us, but we've had clients ask us for carbon footprints and energy efficiency studies from the 90s. So this isn't new for us. It's just that it's becoming front and center of what we're doing.
Thank you. And I think, as I listen to you both, sort of as we talk through, how do you get to a net zero facility, whether it's brownfield or greenfield, and we started to talk a little bit more about other areas of the economy that also need to adapt and change. We can take some of the lessons from oil and gas, and maybe even vice versa as well. And some of the learnings you've got there, Duncan, from the automotive industry is very interesting. But of course, to be able to understand and make that all work, it's pretty complex. There's a series of things you can do, and a lot of things don't sit in isolation. They obviously are impacted by a number of other sort of complex issues. So how do you actually think about, and I think you started to mention this in your intro as well, but how do you think about some of that complexity? How do you deal with that?
Yeah, I think, absolutely the complexity, and in fact, the climate emergency and indeed pretty much everything that we've discussed today would be considered as a wicked problem. So that's a problem that's difficult to solve because the requirements are sometimes incomplete, they're sometimes contradictory, they might be competing, quite often difficult to recognise. And when you have that confluence of uncertainty and complexity, there's rarely one ideal solution that serves all of these competing requirements, and we're having to make trade-offs, and that's fundamentally what we're having to do here. We have to balance the complexity, the opaque nature of some of the requirements, and the ultimate goal of net zero, or of addressing the climate emergency. And the way that we do that is to take a systems approach, based in systems thinking and systems engineering, where we model the systems with what we would talk about precise simplicity. What we mean by that is we model it with enough detail to be insightful, but not so much that we drown in the detail. And this lets us understand the interdependencies between different elements of the system. If I change something over here, what does that do to the rest of my system? If I want to make this metric over there net zero or zero, how does that impact the rest of my system? And when we have that model and we understand those interdependencies, then we can start to make the trade-offs with a little bit more certainty and a little bit more confidence in terms of what we're doing. And quite often we find that when we start talking about modeling systems and looking at interdependencies, people sometimes get anchored on the technical elements, but it's much more than the technical elements. We build in the strategic elements of whether it's client or government desire, but also economic elements. So we're starting to provide an overview of a techno-economic system that we can then adapt and understand to optimize the decisions that we take.
Are you optimizing ultimately for net zero in something like that? So you're saying, what is it? So I've got a problem here. These are all the different options I have, but ultimately my main constraint, let's just say, is the Paris Agreement, or at least the path to getting to Paris. And as you'll know, when you've done your science-based target initiative, there's a pathway to follow within that. Is that how you think about it ultimately, that you're trying to constrain the model to get to net zero, and therefore you're doing it that way, or can you constrain it differently?
In reality, there's never one optimizing factor. There's never one constraint. We are seeing now with many of our clients that there is an emissions element to the optimization. At IO, as part of our commitment, we will put a greenhouse gas emissions optimized solution on the table, whether our clients are asking for it or not. So when we give them options, we will include a low emission option there as well. But it's very often a trade-off between emissions, but also the economics of that. And that's not to say that we're only, we as an industry and our clients and us are only interested in reducing emissions up to a certain dollar value, but rather it's about balancing where you invest to make the most significant impact. So there's a trade-off there in terms of, you don't want to throw billions of dollars at the last 1% when you could be focused somewhere else, making much more significant reductions for a lower value. So the optimization of the system, yes, it is around net zero, it is around emissions, but also there's the other factors, that wider system view that we take to make sure the trade-offs are as good as they can be.
So Duncan, I think it's probably worth adding, some of our clients are coming to talk to us about what the scope for decarbonisation would look like on their asset. And part of the discussion, in the framing discussion, would be looking also at, are we just focused on decarbonisation, or some of the decarbonisation solutions in the trade-off have impacts on other areas. So, for example, if we're looking at solar as a solution that is owned by a solar farm that's owned by the operator, what impact does that have on land take and land users? Are we impacting their ability, the community's ability to farm that land? So it's looking more at the UN sustainability goals and understanding issues associated with that decarbonisation solution. So that's one consideration. Another consideration is hydrogen. At the moment, hydrogen is a great power source for decarbonisation, but the technology really isn't there for 100% turbine solution that will deliver a NOx emission to the same degree as a gas turbine. So there's a bit of a trade-off there. I mean, it's not to say that it's not coming. Industry is working at building these machines to do better, but it's about flame temperature that hydrogen burns at, and if you burn it with air, you have the this increased NOx generation. So that's another thing. Another thing that we would probably bring up at the framing session is use of water. So when we look at perhaps looking at solar panels, the efficiency of those solar panels decline with how much dust sits on them. And, if we're working in an area that might be water constrained, those are the kind of issues that we'd bring up. They do need, the panels need cleaning frequently. What do you do with the water that comes off these panels? Where do you dispose of it? It's looking at the full picture rather than just looking at decarbonisation. I mean, is that fair to say, Duncan?
Yeah, I fully agree, and I think there was a book out earlier this year, Under a White Sky, by Elizabeth Colbert, and she's got some fantastic examples in there of what happens when we as a species interfere with a system, a natural system, without making efforts to understand the impacts as that ripples out through the system. And there's some quite worrying examples there, and she does it in the context of the climate change and some geoengineering ideas that are being thrown about as potential solutions. But it's exactly as Safina describes. It's very easy to go into a system and make a point change that we think is going to improve in one area. But unless we understand how that ripples out through the wider complexities, then we do run the risk of making things worse when we try to make them better.
Substituting one problem for another.
Thank you both. Very interesting indeed. I think we have run out of time, I'm afraid, but thank you both. That was really interesting. I think we had a couple of book recommendations in there, so I've certainly read one of those too, and you find out some very interesting things about your carbon footprint. So I'd certainly recommend that one as well. But no, thank you. I mean, it's been really insightful to talk both around sort of just individual facilities from a greenfield and a brownfield perspective when we're thinking about a lower carbon future. And it's certainly not easy. As you say, there's costs to think about, but also the need to collaborate and work together to achieve some of this. But also, as you both also talked about very well there, the kind of system thinking approach being so critical. So unintended consequences don't come out, but also so you balance all the different things in that complex system to make sure you get the result which actually works as well. So thank you.
Thank you for having us. It's been a joy.
Yeah, no, thanks, David. Really, really good this morning. Thank you.
Perfect. And thanks everyone for listening as well. I hope you enjoyed it. Please make sure you subscribe, give us a good rating, and share with your friends, and talk to you next time.